In this video, we're going to talk about matrix properties and operations. So I want to take another look at what a matrix is and how we can represent each of the elements within, it's called an array. And then we're going to talk about what kind of operations we can perform on a matrix. We can add them, we can subtract them, we can multiply them in a couple of different ways, and so we want to take some time to talk about that. First of all, this is matrix A, okay, and usually we use a capital letter to represent the whole matrix, and then we use a lowercase letter to represent what are called the elements of the matrix, the numbers that are in the array, which is organized like this sort of rectangle with rows and columns. In general, this is the way we represent these elements. We name them by the row number and then the column number. I tried to describe that here. This is a little bit more general. Sometimes it's written like IJ as the coordinates for the A, where I is what row it's in and J is the column that it's in, the element we're talking about, right? So this is the first row. Rows are horizontal. I always have to remind myself of that because I get them mixed up really easily. And these are the columns, first column, second column, third column. So this element right here at the end is in the fourth row, third column. And that's where this 4, 3 comes from. We can also talk about the dimension or the size of a matrix. So the size of this matrix is always going to be described by the number of rows. The X here is like a by, like a 2 by 4, and then the number of columns. So this matrix up here that we've already been describing, this has 4 rows by 3 columns. So we say it's 4 by 3. Okay? So that's just a general way, that notation is a way to write something. This is just the general kind of convention of a way to write a matrix when we're speaking in abstract, right? We don't have numbers yet, we're just referencing the elements. That's a very common way to label them. Okay, adding and subtracting matrices together. To add or subtract them, they must be the same dimension or the same size because we're just going to add the corresponding elements. So for the first row, we're going to add the first element plus the second element plus the third element, okay? So for example, for this one, I have a matrix A and matrix B. If I want to add them together, notice they are the same size, 2 rows, 3 columns. Let's write that down. So they're 2 by 3. Same thing here, 2 rows, 3 columns. I can add them. I know you could do this directly, but I'm going to do it in 2 steps just to be super obvious. So I'm going to add the 7 plus 5. I'm going to add the 8 plus -2. I'm going to add the -1 plus 10. I'm going to add 0 plus -3, -1 plus 2, and 6 plus 4, each individually. And when I add them up, the result I get is a matrix of the same size. So I'll have 12, 6, 9 in the first row, -3, 1, 10 in the second row. Okay, so to add or subtract, we would do that in the same fashion, and we would just add the corresponding elements, right? Each of the elements that are in the same location. I can also multiply a matrix by just a regular number. A regular number, right, without a variable or any extra notation or meaning to it, just a number is usually called a scalar. So I'm just multiplying by a real number, okay? For example, I'm going to multiply matrix A up here by 3. When I do that, I multiply every element, all the elements. Not just the first row, not just one of the elements, everything. So I'm going to multiply all the elements in matrix A by 3. So that means, I'm referencing this matrix up here, I'm going to do 3 times 7, 3 times 8, 3 times -1, 3 times 0, 3 times -1, and 3 times 6. And I'm going to end up with 21, 24, and -3 in the first row, and then 0, -3, and 18 in the second row. Okay, and we've talked about doing this row by row, not really changing the relationship between the rows of the matrix when we do this. Okay, so this is scalar multiplication. I don't think this page number is correct, by the way. You can check this out. We are in section 6.4 in your textbook. Okay, so what if we're not multiplying by a scalar? What if we want to multiply two matrices together? When we multiply two matrices together, the size does make a difference. And so the number of columns in the first matrix that we're multiplying has to match with the number of rows in the second matrix we're multiplying. So not only does the size matter actually, but also the order matters. Multiplying them in a different order would not yield the same result. And so that's worth mentioning too. When we multiply two matrices, we're going to multiply each row of A by each column of B to get one element. Okay, so that's really hard to describe in words, so let me show you what that would look like. Notice I'm going to write down the size because, like we said, that does matter. This is 2 rows, rows are horizontal, by 3 columns, so this is 2 by 3. And I'm multiplying it by a matrix that has 3 rows and 2 columns. So when I'm done, you could kind of, I don't know if I've seen this somewhere or I just did it myself, but you could kind of take out these middle ones. They have to match. And when I'm finished, I'm going to get a matrix that's 2 by 2. So let's do that. So I'm going to multiply each row of matrix A, well, let's call this A and B, by each column of matrix B. Okay, and I'm going to write this out in a very overdone way. Just to be really clear and obvious, I would definitely do a lot of this in my head, but we're just starting out, so I want to be really obvious. So we're going to multiply 2 times 0, the first element in this row, by the first element in this column. Then I'm going to multiply 2 times -1. I'm adding all these together. Then I'm going to multiply -1 times 0. That's the first row and the first column, so that goes in the result. The answer I get goes in the first row and first column. I'm sorry, first row, first column. Okay. Next, I'm going to multiply the first row by the second column. So I'm going to do the same thing. So 2 times 2 plus 2 times 4 plus -1 times 2 Okay, and notice I've multiplied the first row by the second column, and the result that I get is going to be in the first row, second column. Same thing with the second row of A. So now I'm going to multiply the second row times the first column. So 3 times 0 plus 0 times -1 plus 1 times 0 And I'm going to add those up just the same. Then second row times second column. 3 times 2 plus 0 times 4 plus 1 times 2. Okay, and I'm going to calculate what each of those is, and that's going to give me my result. I'm just going to write the result over here so you can see it all on one screen. So 2 times 0, that's 0. 2 times negative 1, that's negative 2 plus 0. So this is negative 2 when I did the first row times the first column. This will be 4 plus 8, that's 12, minus 2 will be 10. And then this will be 0 plus 0 plus 0. This will be 6 plus 0 plus 2. Okay, so we got our results. I hope you can see that process. If you need to rewind and watch that again so you know where these numbers came from, then make sure you do that. I think once you've done this a couple times, you could probably start doing this calculation in your head. But it takes a while to get comfortable with the process. Okay, I think I have one more of these. Let's try this one. Just to keep track of the size, I think that's a really good idea to start out with. So we have 3 rows and 2 columns in this first one. Let's call them A and B again. We have 3 rows by 2 columns. And in B, I have 2 rows and 3 columns. So you could think of the 2's going away, and my result is going to be 3 rows by 3 columns. Let's do it the exact same way. Okay, so we want to multiply the first row of A by the first column of B. So that means 5 times negative 5 plus 1 times 0. Then we're going to do the first row times the second column. 5 times 4 plus 1 times 3. First row, second column. Then we're going to do first row times third column. 5 times 1 plus 1 times 6. Okay, so that we used the first row of A, and that gave us all 3 elements in the first row of the answer. Now we're going to use the second row of A. Second row times first column, so 0 times negative 5 plus negative 2 times 0. That's first column, second row times first column. Now second row times second column, 0 times 4 plus negative 2 times 3. And then second row times third column, 0 times 1 plus negative 2 times 6. Okay, and then we'll do the third row. Third row times first column, 3 times negative 5 plus 7 times 0. First row times second column, 3 times 4 plus 7 times 3. Third row plus third times third column, 3 times 1 plus 7 times 6. Okay, just like before, right, I'm writing it out here to be super obvious so you can get a good handle on the process. I would eventually be doing these in my head. This would be negative 25 plus 0. This will be 20 plus 3. 5 plus 6, and then 0 plus 0, 0 minus 6, 0 minus 12, and then negative 15 plus 0, 12 plus 21 is 33, right? 3 plus 42. Okay, notice we got a matrix that's 3 by 3 as a result. This also is a good idea that you can watch someone do it to get the understanding of how the process works, but then really you need to sit down and try this out. So go find some examples. Yeah, I'm sure you've got some online, definitely in the textbook, where you can make sure you know how to carry out this process. All right, good luck.